I'm Dr. Robin Williams, and for today's tour, we're going to visit the historic Central of Georgia Railroad Repair Shops complex in Savannah, which is one of the best preserved 19th century railroad facilities anywhere in the world. With its ensemble of buildings dating from the early 1850s through to the 1920s, it provides a glimpse of the evolution of industrial architecture from the days before electricity through to the technology and safety standards of the early 20th century. The Central of Georgia complex was an innovative, integrated design, incorporating passenger, freight, and repair service, as well as more high-style buildings housing the corporate headquarters and design department, with most of the buildings believed to have been designed by German immigrant engineers Augustus Schwab and Martin Muller. Construction of the complex began in 1851 under the supervision of superintendent and self-taught engineer William Wadley, who would later become president of the company. The complex occupied a 33-acre site along the western edge of the city. Join me as we explore this most remarkable survivor of our industrial heritage. We've now entered the Central of Georgia Railroad Shops complex, what's today the Georgia State Railroad Museum. So as we explore this complex, we're going to look at the variety of operations that this complex served for the Central of Georgia. Everything from maintenance shops for the engines to fabrication shops, blacksmith, carpentry, and painting. So here we are at the Roundhouse complex. Behind me is the 1920s roundhouse, but where I'm standing is the inner edge of the 1850s roundhouse. This granite pedestal would have had an iron or wooden post on it, and you can see others of these post bases. That the original roundhouse was much smaller, with a smaller turntable, and the roundhouse had to be expanded as the engines got bigger and bigger. The wall to the gift shop represents the original back wall or outer wall of the roundhouse that is probably a good 50 or 60 feet farther forward than the current back wall. And you can see how this boxcar extends beyond that wall. So as we visit this space, we can see that the diameter of this current roundhouse is so much bigger than the original. Now behind me, you can see a green passenger carriage, a couple of engines, one diesel, one steam, and then a reddish boxcar. The roundhouse would have only been for the engines, the steam engines. So let's go inside and check out how these roundhouses worked. So here we are inside the roundhouse, the purpose of which was to care for the engines overnight. So an engine is used out on the tracks, and when it needs maintenance every certain number of days, they would bring it into the roundhouse, but they wouldn't turn it off. These are steam engines burning coal, belching out smoke, and spraying off steam. They would come in here to do maintenance and to be re-oiled and whatever repairs need to be done. So when the engine pulls in, like the steam engine you see behind me, it pulls in so that the smokestack is centered underneath one of these large triangular hoods, which are known as smoke jacks, which helps evacuate the smoke out of the roundhouse and makes it a healthier environment. If you look to the right, you'll see a series of large windows, and the windows, one set of which have been restored, provide tremendous amount of natural light. These are triple hung windows, so that the upper sash can go down, the lower sash can go up, and you could move them all down, all up, and provide ventilation into the space as well as ample light for the workers. This expanded warehouse is made out of reinforced concrete, and that is a material where you lay a mesh of steel that you can see, for example, in that rusty section, and then you pour concrete around it. So the steel is like a mesh or a web that reinforces the strength of the concrete and allows it to span these large open spaces. The columns are also made out of reinforced concrete. So this is all from the 1920s and was necessary because the engines kept getting bigger and longer as we move into the 20th century compared to the original smaller engines. Now, another aspect that's distinctive about this is the wooden floor. And if you look carefully, you can see that the pavement in this space is wood blocks. And the blocks that we're looking at right now are historic, and they've got a bit of sludge. But if we look at some of the restored ones that don't have decades and decades of oil building up on them, you can see the wood grain coming through. The advantage of the wood block was not only was it softer underfoot for the workers, but most importantly, oil dripping off the engines could be absorbed into that end grain and make this a safer working environment. One other advantage was that if they're working with cast iron tools on these engines and they drop a tool, if you dropped onto concrete, the tool would probably shatter. But by working on, or if they're working on a stone floor, any kind of hard surface, but with this wood block, if you drop something on this wood block, it would bounce or at least not break. So here's another view of the wood floor. We're by one of the engines, and we can see how these trains would have pulled into the roundhouse. The tracks originally had a trench underneath that has since been filled in, but basically where you see the wood up ahead here and what's dirt between the tracks originally would have had a trench, and so that they could work underneath the engine. But there's the boiler. The smokestack would have evacuated the soot, and behind the engine is the tender that carries the fuel for it. But these locomotives would have had all sorts of parts that needed repairing over the course of their day or their use, and the railroad shop, the roundhouse, was an essential component in the life of an engine. Just for point of comparison, the engine we were just looking at a minute ago was an early 20th century engine, and the one in front of you now is a 19th century engine. It was about 1/3 the length of the later engines. Originally, the roundhouse would have formed a near full circle, but only about half of the roundhouse stands that survives today. At the center of the roundhouse is the turntable, and as you can see, the tracks radiate out from that central table, and the table pivots on a central post, and in fact is so well balanced that it doesn't take much power at all. Originally, it would have been human powered. This one is electric, and you can see the cable up at the top. Over the years, the turntable was expanded and expanded and expanded in size to the current size of this table. Earlier ones would have been much smaller. And you can see a track enters onto the table. This table would have aligned with that track, and then it pivots depending on which bay of the roundhouse it needs to put the engine into. And as we pan around, we can see the turntable, which is in a kind of deep trench that is like a steel truss that pivots on a single pin. So the Central Georgia complex has a series of buildings that are all interconnected. And one of the reasons for this is because the power, this complex predates electricity. In the 1850s, the way you delivered power to different parts of the complex was by means of line shafts. The longer the length of a line shaft, the less power it has the farther away you get from it. So having the buildings all compact, physically joined one to the other, made for a more efficient delivery of power. So the space we're in is the machine shop. It's attached to the blacksmith shop, and beyond that is the powerhouse that we'll be seeing shortly. So what is the machine shop? Well, this space originally would have had a roof that unfortunately fell down in a hurricane in the 1970s. So the machine shop had a series of machines that were sitting on these concrete pads. You can see a few stone or concrete pads around the perimeter, and there are others that you can't see that are in this space, some overgrown by grass. In the far corner of the machine shop, we can see a little opening right up here, and that's where the line shaft would have come out. And that conduit pipe running down the side wall sort of evokes what the line shaft would have looked like. And it would have been attached to the wall where you see these smudges of yellow, which are sulfur, and these sulfur pads are all the way down the line of the wall. And there would have been a bracket where each of those is. The shaft would have run down the whole length of this space on both this wall and the opposite. Central Georgia Complex has a line shaft demonstration structure that Sarah will turn on and give us a sense of both how noisy and how many moving parts were going when a line shaft was powering a series of machines. So here we go. So you can see the drill press, the Buffalo woodworker, and metal planer, 3 machines, all with belts attached to the line shaft up here, and then the belt comes down the machine, and a worker could disengage that main belt attached to the machine by means of a clutch. So the line shaft never stops moving, but you could turn off a machine, as it were, by disengaging the pressure on the belt. And if we come around here, we can actually see the right underneath, we can see a red lever there, and that's the clutch. So a worker would pull on that lever, and that would release the pressure on this belt here, and the machine would, or the belt would actually slide over onto that other wheel that you see there, and essentially allow the machine to stop if they need to change a drill bit, do maintenance, or if something went wrong. And these square sockets are where a beam would have crossed the space, and these are called fire cuts. And it's like a metal sleeve in the side of the wall, and they are on both on this side, and if we pivot around, it might be easier to see both the sulfur smudges. You can see where the line shaft brackets were attached, here, here, and here. And then above them are the metal sleeves that were sockets for the beams. And the idea was that in the event of a fire or some other catastrophic event that caused the beams to fail, let's say rot or something, the beam could basically fall out of that socket, the upper part of which is sloped. So it's got a slope on the top and it's flat on the bottom. And when a beam falls, if the beam fell, it would heave up. But this way, it would just slide out of the metal sleeve without damaging the brick around it. And the fact that this ceiling collapsed, this roof collapsed, without the walls collapsing, is a sure sign that these fire cuts actually were successful. The Tender Frame Shop, which has the first story built in the 1850s, and then the upper story you can see with a different color brick, a much smaller hard-pressed imported red brick made in a factory compared to the lower Savannah gray, larger local brick. So this was where they would create the frameworks for the tenders, which are like the storage carriage that carries the fuel for the engine. The space we're in is just outside the machine shop that we were in just a few minutes ago. And over here is a garden and the back wall of the roundhouse. And so we're in this the east end of the complex. And the garden actually is historic. There's always been a garden here. And the idea was the person who managed this part of the complex believed that gardens were a healthy part of the work environment, that employees could grow their own food, they could have roses here, and it just made the work environment that much nicer. So we're going to be heading towards the power plant, which is a couple buildings down the way, and give us a sense of how power was delivered to all these buildings. We're back in the machine shop, and we're going to head through this arch over to the power plant and the blacksmith shop. So the blacksmith shop is the building that we're going to see on our left, and the power plant is the little castle building that's just beyond. So in this courtyard here, the dominant structure is the chimney. And the chimney is really one of these amazing things that survives from this complex. So here we have on the right, the backside of the roundhouse, the 1920s roundhouse, and then the chimney, which we'll be talking about more later, dominates this space and was at the time one of the tallest structures in the city of Savannah. So here we are in the blacksmith shop, and this gives us a better sense of what the machine shop would have looked like originally, with its wooden roof, with the trusses spanning, and the monitor area above for ventilation and light. So this building would have been filled with a series of blacksmith stations, and on both sides of the building. So although a line shaft worked its way down the side of the building, there were no machines attached to the line shaft. This building was merely a pass-through that took the line shaft to the machine shop. So why is it here? The blacksmith shop had these blacksmith stations, and each of which had a fire going with an anvil and a blacksmith working away at the tools. And what's really cool about this space is that the stations, and if we pan just over here, we can see a few bricks in the floor. You have to imagine there being a station here, and they'd be working on the station, and the smoke would be, rather than going up into the space, the smoke would have been sucked down into the station by means of underground flues or ductwork that pulled the smoke to the chimney that's just outside this building. So the reason this building is here, even though it didn't need the line shaft power, is being close to the chimney was absolutely essential. And next door is the powerhouse, and it too was generating smoke that had to get close to the smokestack. So not only is it important that the buildings are close together for their line shaft technology, but it's also absolutely critical that the buildings that produce smoke be close to that central chimney. And due to the height of the chimney, that created a negative pressure, which basically is like a vacuum. The taller the chimney is, a Brunelli effect allows the air to be sucked up through the chimney. So the blacksmith shop is where they would do all the metal work that had to be done by hand, fabricating individual parts or small castings, and anything that couldn't be done in the machine shop would be done in the blacksmith shop. So one of the themes that I've been talking about is how did they build this complex to be safer for the workers and make the work environment better, so that underground evacuation of smoke from the blacksmith stations through the underground pipes is one method, and that was an extraordinary feature for this factory complex. More typical of factory architecture broadly are actually splayed. They are wider on the inside than the window itself, and the walls, it's not straight cut to the window, but rather it's almost like a funnel on the inside. And this allowed the light to spread out in the workspace much better. Also, the windows are large to allow for a lot of light and ventilation. And then if we look up, once again, we can see those marks for the line shaft, those sulfur smudges that carried the line shaft down the wall and through that opening at the end of the wall, which took the line shaft into the machine shop next door. But above us is a series of wooden and metal tie rod trusses that help support the roof and provide this distinctive profile which is very typical of factory architecture in the 19th century, having the central section of the roof rise taller to allow for extra light and ventilation and the evacuation of heat in the summertime. One of the absolute coolest aspects of the Central Georgia Railroad Shops complex is this amazing chimney behind me. So as I mentioned, it's one of the tallest structures in 1850s Savannah. It's made of Savannah gray brick, and it obviously was a showpiece that was meant to impress investors, not only by its height, but by this elaborate design of the base structure, which has a series of arches and corbelled brackets that frame a series of little doorways. And I'm gonna give you a second to wonder, what on earth would you use those little arched cabinets for? And well, the answer is restrooms. So these were the white bathrooms. African Americans worked on this complex, but in the 1850s, this was still an era of segregation. The black bathrooms were attached to the roundhouse a few hundred feet from here. So these were used for whites. They not only had bathrooms, but there were shower facilities in these little cabinets, so they could clean themselves off at the end of the day before going home. Above it is a cast iron tank made by a local foundry, the Rose Foundry of Savannah, and it's marked on the side. It's signed in effect. And this cast iron tank is a kind of cistern. Essentially, it would catch the rainwater, or they could put water in it, but it obviously caught rainwater, and effectively the water would be warmed by the heat going up the chimney. So it was a kind of a fascinating early example of taking advantage of one situation, the heat going up the chimney with the smoke, benefits the water that could then be reused, or used rather, for the workers. And the whole structure is not only helps for the workers, but provides a kind of base, all of which is ornamental and would be a kind of showpiece, so that they brought investors to the complex, they could say, look where your money's going. And this would be high-tech, impressive industrial output for the time. So let's go inside one of these little chambers, and we can see the brick walls that lead in. And in fact, we'll be able to see when we look over that it drains down into, now it's full of debris now, but this would have drained into a cistern or some kind of sewer system. So for anyone who's seen the movie Glory with Denzel Washington and Matthew Broderick, this vantage point might be familiar because they filmed the movie Glory in Savannah, and this courtyard was used for some of the scenes, which is appropriate since the building complex did predate the Civil War. So from here we can see the back of the roundhouse, the chimney, and in the distance behind the young woman sitting on the concrete with the helmet, waving at us. Just beyond her is the machine shop, and then we have the blacksmith shop, and finally the powerhouse. Behind me is the powerhouse, which by its sound is critical to the success of this complex. It's here that the power was generated by means of a steam engine that then transmitted that power by means of line shafts through the blacksmith shop to the machine shop on that side, and then to the carpentry shop and other buildings farther behind to your right. Now the powerhouse, as you can see, is dressed up like a castle, and that was like the chimney, it was dressed up to be a showpiece, a kind of an impressive element. So it reminds us that although factories were generally closed to the public, but companies like the Central Georgia required investors, capitalists who, like venture capitalists today, were willing to invest and put money towards this newfangled technology known as railroads. And the investors wanted to see evidence of where their money was going to. But the ornament also was hierarchical. It indicated what was most important in the complex, even in the minds of the workers. So dressing it up like a castle evokes a sense of strength and was symbolic of not only the power that comes out of the building, but strength of the company. So inside the powerhouse, we can see some extraordinary things. So even though it's basically an engine room, it too was dressed up on the inside. On the far wall behind me, you can see plaster and just the slightest hint of scoring. So the inside walls here were stuccoed and scored to look like masonry, a technique we've seen on other buildings in Savannah, and was probably originally painted. Now, it's kind of strange because this space had a steam engine in it. Now, the original engine's long gone, and the engine would have been comprised, first of all, the boiler, where you cook the coal and heat up the water, which creates pressure. And that boiler that we see behind us is not as big as the original boiler, but it would have been connected to the machine that we see directly to the left, this red machine here, which is the engine proper. So let's look at it from a different angle. So the steam engine here would generate the pressure from the heating up of the water, and the water would have been heated up much higher than the typical 212 degrees that you boil water on your stove. Because it's an encased environment, you can see by the circular shape, it would actually boil to a much higher boiling point, create pressure, and at the far end, you can see a little bump. That's known as a steam dome. And from that steam dome, there would have been a pipe that connects over to the engine that you see to your left. And the engine has that cylinder at the left-hand end, and the pipe would have come down into that spot and transferred the pressure and pushed the piston. The machinery of it would have allowed the piston to go back and forth, pushing the arm, which turns the wheel in behind, and that would have turned a bigger wheel. So let's find a different position here, and I'll show you further how this all works. Although this engine isn't original to the building, it is from the era of the complex. In fact, the engine was manufactured 1 year after this complex was created, and it's an engine from elsewhere in Georgia, from Macon, Georgia. The piston chamber here would have pushed this shaft, which then turns. As the shaft moved, it turns this wheel, which a big flywheel used to be here, the spokes of which are still here, but the flywheel was cut off at some point in history. But from that big flywheel, a belt would have risen up to the line shaft that went through that door. In fact, the line shaft would have passed across this room and gone through a second doorway, which has since been bricked up, but you can see it right there, transferring the power both to the west into the Carpentry Shop and through that other opening to the east through the Blacksmith Shop into the machine shop. So here we are in the tender frame shop. Sarah will turn on the steam engine, which will give us a sense of how this technology works. Although originally there would not have been a steam engine in this building, but it's where they show this very, very old engine, which was constructed in Charleston in the 1858, so very early in the history of steam engine technology. So here we go. So you can see the energy created by the engine is in the piston, pushes the crank, which turns the arm, which turns the wheel. And spinning on the top is called the governor, which would keep it from going too fast. So as those two balls, as it goes faster, the two balls would move farther and farther apart and ultimately prevent the engine from self-destructing. On the east side of the powerhouse is the opening where the line shaft left the inside of the powerhouse and crossed this opening to then pass into the blacksmith shop. But the opening on the outside is a cast iron panel with this opening, and the cast iron has actually got some decorative motifs on it to evoke the brickwork to continue. So it's an amazing attention to detail that just reinforces how important the was in being dressed up. So it's not just a mere hole in a wall. And quite shocking is the contrast between that and when we look across to the other side, we can see that the opening going into the blacksmith shop is really crude and not dressed up at all. You can see black gunk, decades and decades of grease used to lubricate the shaft as it passed through the wall. The Central Georgia complex also takes good advantage of the change of topography. At the area where the complex is below the level of the street, you can see a series of arches that originally were chambers that were for the collection of coal, that they could deliver coal to the site by having trucks on Jones Street, and they'd have openings, they'd have compartments, they'd just drop it into those coal chambers. Another feature to point out, and something we're going to be talking about more when we go down to the waterfront, are these flanges that you can see, 3 of them here and then 1 to the right. And these are known as earthquake bolts. And they have a tie rod that passes through the building, and there'd be a corresponding plate on the other side, or flange. And think of them like bookends, and that they are screwed together and that you can tighten them. And these are on any building that would have predated the 1886 earthquake that shook Savannah. So to help stabilize the buildings in the city, earthquake bolts were added. So this one has 4 up at this corner. There's a later one there, and there's even one down at the bottom by the entrance. To the west of the powerhouse, the buildings continue to be connected, and as we pan to the right, we can see just the top wall of the carpentry shop that we're going to be looking at in just a moment. But we have to pass around this later building, this early 20th century building that was used for print materials for the Central Georgia. So this was where they had all their printing presses and storing facilities. And so this was not part of the original 1850s complex, but it's an evolving complex. And this complex continued to develop up until the mid-20th century. So just west of the roundhouse and the smokestack and the blacksmith shop and all that is the carpentry shop and the paint shop beyond. And these areas were, instead of using a roundhouse to bring the train coaches into this area, and these would be just for coaches, not for the engines. The engines were in the roundhouse. The box cars and other flatbed cars and passenger coaches would all be maintained in these sheds behind me, in these buildings. Now, to get them in, instead of a train coming into a roundhouse and a turntable, rather they come onto what's called a transfer table. In understanding where the transfer table was, you have to wish away the little mound, the trees, this path. So there were tracks, a trench with tracks underneath here, and then a platform rolling up and down, and then tracks on that platform perpendicular to these buildings. So if I were one of those coaches, I would be moving into this building and go through that door behind me into the carpentry shop. The current state of the carpentry shop as the Children's Museum makes it really hard to understand how this space originally looked. So those arches down at the bottom that you see at the lower left and in the middle supported the floor that then had all these lathes and drill presses and other and saws and bandsaws, every kind of carpentry tool imaginable. There would have been a series of trusses in these fire breaks, but the line shaft came across from the back, and like the machine shop, had shafts running down both the east and west walls. So this building also lost its original roof as a result of a fire that ultimately destroyed the 1850s paint shop next door. So we're going to visit the paint shop, which is a more modern building from the early 20th century. The biggest building in the complex is the 1920s paint shop. And so here we can see it extending from here on the left all the way down towards Boundary Street. And these large doors originally allowed carriages and coaches to be shunted in and maintained and painted and whatever else needed to be fixed on them. So here we are inside the eastern part of the paint shop, and this large construction illustrates early 20th century industrial production and construction. In other words, how were factories made in the early 20th century differently from what we saw in the early 19th century? So you can see that the scale of this space is so much bigger than the earlier factory buildings. The ceiling that you can see above you here is made out of steel trusses, and running down through we have a ventilation system, and harder to see, but you have to trust me is up there, is a sprinkler system. These pipes with the usual sprinkler heads. Now, down below, they've been excavating the building to reveal the foundation arches of the earlier building that was here from the 1850s, onto which they sat the 1920s paint shop construction. Now, one of the key strategies for preventing the spread of fire in this space was the series of metal fire doors, which you can see are on this track, and they're held open by a little lead tab originally. So if a fire broke out at a time when no one was in the building, the lead tab would melt before most other things. Lead is a very low melting point, and once that lead tab melts, gravity would slam the door shut and help prevent fire from spreading from one part of the building to the other. So the reason I'm wearing a helmet under here is because of this reinforced concrete foundation structure, the basement area of the paint shop. And as you look up, you can see they've put some modern patches, but this is reinforced concrete construction, and these piers and beams would have been formed by pouring concrete into a matrix of iron inside of a formwork or mold. And above my head here, if we come in and look up, you can see that the beams are reinforced with these thicker sections where tracks would have been above. And so each of these sections where I'm standing in between a pair of piers corresponds to a track that we will see upstairs in the paint shop proper. Here we can see another one of those fire doors, and we're going to pass through it into the next section, passing through this old demising wall, this brick wall that helped contain the fire from one section to the other. And we're entering the lower story of the paint shop, is where they would do repairs, they would mix paints, they'd have a chemistry lab. Once again, we can see how these beams are thicker where the tracks are above, but we can also see the damage caused. Well, we can see the reinforcement, the steel reinforcements inside the concrete. But the problem with reinforced concrete is if any moisture gets to the steel, it will rust. And as it rusts, it expands, and it cracks the concrete, which spalls or flakes off, and it can fall in small and big pieces, and hence the need for a hard hat. And so as we look around, we can see both the concrete spalling, why I'm wearing a helmet to protect my head from the falling concrete, and we can see that this space needs some repairs. All the glass is long since gone, but this space is very evocative of early 20th century industrial architecture. Inside this building are this graffiti, basically, these little notes written in pencil by the workers who might not have had paper readily available, and in the course of their day just jotted down a little note. And these notes date from the early 20th century through to the closing of the complex in the 1960s. So not only do we have this modern graffiti, but we have a record of the workers who worked here and who used the architecture as a kind of note paper. So for example, we can see all sorts of dates from 1934, 1937, 1939. One can see at the west end of the complex were actually below the ground level of the majority of the complex, and yet we're above Boundary Street, which is outside these windows. The windows themselves are metal sashes, and as opposed to those wooden sashes that we saw at the beginning, actually these are casement windows that pivot, and you can see that the lower parts pivot open, as do the upper parts, and they would have been joined by a rod and open mechanically all at the same time. Metal mullions holding the glass panes in would have been considered more fireproof, and we can see also some of the sprinkler system up above, and over by the stairs is one of two freight elevators that would have been used to carry supplies between the two floor levels of this building. Here we are in the upper story of the paint shop, which is well above the ground level outside, but level with the rest of the complex. The coaches, like the ones you see behind me, would have come in through these big doors from the transfer table that we saw outside, and it's in here that maintenance could be done, principally painting or repainting, but also they could do upholstery repairs. Above our heads is a great example of what we call a sawtooth roof that has a steep slope over on the left here that would have originally had windows, and then the long slope which has this wooden decking. So it would have been windows here facing north and more windows on this piece right here, and then another slope, and on and on and on all the way across the building. The key to the fact that these windows originally were oriented north, like the light that's coming in through the doors right now, it provides an even ambient light as opposed to direct light coming in from the south. So not only do they get nice even light that is not too hot, not too cold in the sense of the color temperature, but also it's more ambient, it's diffused, and so for doing painting, it allowed for a much more accurate ability to paint the carriages. So these box cars, this yellow one and there's a brown one to my left, to your right, illustrate the kind of coaches or service cars that would have been brought into this building for repainting and repairs. So connecting the complex from the paint shop to the roundhouse to the outside world was that viaduct in behind me, one of two viaducts that cross the Ogeechee Canal and West Boundary Street, and are amazing examples of arched construction. And they date to the 1850s, from the beginning of the complex, and tracks from the west would have come into the complex and crossed Louisville Road and come into here, and we can see right behind me tracks that circle around and lead still to this day into the paint shop. So this concludes our visit to the Central of Georgia Railroad Complex, which is a representative example of industrial architecture. So we've seen the evolution from 1850s through 1920s industrial architectural technology, from the use of coal-burning steam engines as a source of power through to the introduction of electricity. And the evolution also of features that made the environment safer for workers, as well as fire prevention and fire suppression techniques.